Good afternoon. We're Team Buzz, and our Capstone project is the HyTech Racing Battery Management System. Team Buzz is a group of 6 mechanical and electrical engineering majors with background mainly in embedded systems, power systems, circuit and PCB design, thermodynamics, and fabrication. HyTech Racing is an award-winning, student-run Formula Electric racing team at Georgia Tech. Our project is centered around building HyTech Racing a custom battery management system for charging their Lithium Cobalt Oxide pouch battery cells. This system is intended to speed up testing and prototyping in their workshop.
Alright, so here we have a more detailed problem statement and list of requirements from HyTech Racing. First off, HyTech wants a battery management system that provides a user-friendly interface for charging their Lithium Cobalt Oxide pouch battery cells. They also want a data recording system to be built in to the overall BMS unit, as well as a way to estimate the state of health of all of the individual batteries being charged. So moving on to the requirements, here we need to be able to charge at least 9 battery cells at a time at a supply voltage of around 38 volts and 10 amps of current. Also, the voltage and current data for every battery cell must be collected and recorded. And during charging, a cell balancing algorithm must be implemented to make sure that each battery cell is at the proper voltage. And the overall device must be safe and easy to use.
There are a number of engineering constraints that need to be taken into consideration for this project. Mainly, the chemistry of the cells, which will determine the range for charging, as well as other aspects like its temperature. Likewise, the safety of the user must also be considered in order to prevent electrocution. This means the materials chosen to house the cells need to be good insulators, and the design should minimize the risk of a short circuit or human contact with energized components.
Various engineering goals for this charging device were laid out. From a software perspective, the device should engage start and stop charging sessions. It should reliably log voltage, current, and temperature of the batteries, and also perform calculations to gauge the health of each cell. Electronically, the correct voltage and current levels needs to be delivered to the batteries. It also needs to ensure that the battery cells remain stable. The physical device should have a robust design. It should last 5 years under regular use, accommodate variance in cell dimensions, and be fairly insulated. It should not transmit heat or warp from current.
This custom battery charger is designed to work with 18 amp-hour lithium cobalt oxide pouch battery cells. The body of the charger is made out of HDPE plastic, which provides electrical insulation and excellent durability to the device. The charger can work with up to 9 battery cells. Each battery bay is separated with a divider, which allows for easy cell installation and safe battery handling. The device also includes cell tab dividers, which prevent the user from accidentally shorting battery terminals. The cell tabs are secured with toggle clamps. Each clamp has an aluminum bus bar, which creates electrical contact between adjacent battery cells. The positive terminal of one cell is connected to the negative terminal of the next, connecting all 9 batteries in series. The toggle clamps are completely insulated from the battery terminals, and no energized connections are exposed to touching. The entire procedure is simple and straightforward, which prevents the user from damaging the batteries or causing hazardous situations. After all 9 cells are placed into the device, the batteries are ready to be charged. The custom battery management system is responsible for monitoring cell voltages, temperatures, and charge current. It also includes a cell balancing algorithm, which ensures even charging across all 9 batteries. The BMS indicates which cells are being balanced by lighting up corresponding LEDs. The user interface consists of a keypad with a screen. The keypad allows the user to enter cell IDs and activate charging. During the charging process, all cell voltages and currents are actively monitored and recorded on an SD card. This makes it possible to later use the data for battery cell characterization and analysis. The charger is also capable to estimate battery cell health through capacity analysis.
The following slides show our design solution. Here you can see our general system diagram with major components in their own blocks. On this slide, you can see the controller board with different components as inputs and outputs, as well as the communication protocols they use to interface with each other.